Hey, Math 206 students. This is Dr. McGathy. We are talking about geometry in 3 dimensions today. Um, so what we'll focus on now is definitions and also actually drawing these shapes. And then there's a whole bunch of activities for you to do from the homework. And we'll do some activities during office hours as well. All right, so we know what simple closed curves are that we discussed in section 11.1. A simple closed surface is a surface. It's a two-dimensional object, but that can only be shown in a three-dimensional space. And it has exactly one interior, so that's telling you that it's simple and closed. And it has no holes, so there it's simple. And it's hollow, so it's not all filled in. So here's some examples of pictures of these simple closed surfaces. So we're not talking about the inside of this object, just the surface of it. All right, so the set of all points at a given distance from a given point, the center, is called a sphere. The cross section of a sphere would be a circle here. And you can imagine that there's a center inside of the sphere, and every point on the sphere is a given distance away from that center. And here's how you would draw a sphere. You draw a circle, and then you can go ahead and draw like the great circle around the center, like the equator here, by drawing a curved line on the surface of your sphere, and the extension of that curve in the back of your sphere you can draw with a dotted line. The set of all points on a simple closed surface together with all of those interior points, so if you were to fill in the inside of all these objects, those are called solids. So solids versus surfaces. A simple closed surface made up of polygonal regions, so polygons, which are the faces, which has vertices, are called a polyhedron. So think of like a polygon, but this is a three-dimensional version of a polygon. It's called a polyhedron. And the sides of the polygonal regions are called the edges of the polyhedron. So here's some examples of polyhedrons here, and also up here as well. Polyhedron, polyhedron. This is not a polyhedron because its sides are not polygons. This is also not a polyhedron because you see this top is a circle. It's not a polygon. It doesn't have sides. Okay, so these polygonal regions here, the square and the triangle on the top, these are called the faces. And where the edges meet here, these are called the vertices. And each edge of each polygon here, these things are called the edges. Right? All right, so this is a polyhedron sphere. This is not a polyhedron, but it is a simple closed surface. This image right here is not a simple closed surface because it has a hole, even though it has only one interior, this hole in the middle. So this is not a simple closed surface. And this example right here, this is also not a simple closed surface because it has two distinct interiors. All right, so let's move on. A polyhedron in which two congruent faces, which are called the bases, lie in parallel planes, and the other faces, which are called the lateral faces, are bounded by parallelograms. That's called, and these are examples of that. Those are called prisms. So this is a triangular prism, and it's actually a right triangular prism because the lateral faces, these rectangles here, meet the two bases, the triangle bases, in a 90-degree angle. This is a rectangular prism, and this is also a right rectangular prism. Here you've got 1, 2, 3, 4, 5, 6. The two bases are six-sided polygons, so this is a hexagonal prism. And this one's also a right hexagonal prism. And this object right here, notice that it looks like it's leaning over. So this angle made by the lateral face and the base is not a 90-degree angle. This is an oblique. And it's also made up of a hexagon bases. So a hexagonal prism. All right, so with these examples, let's fill in the next blank. A prism in which the lateral faces are perpendicular to the bases, that would be a right prism. So these three are right prisms because the lateral faces are perpendicular to the bases. And a prism in which the lateral faces are not perpendicular are called oblique. Those are oblique prisms. All right, and here's a way that we draw prisms. So let's draw a triangular prism together. What you would do is draw one triangle for the top base, and then draw another triangle just below it for the bottom base. And then what you'll do is you'll connect all corresponding vertices together by edges. And any edges that should appear in back of your object, you'll connect with a dotted line. So actually I'm going to do this once without any dotted lines. So you see no dotted lines there. And now let me actually draw another time where I keep all the edges that are in back of my object. I'll draw them with dotted lines. So here is my top base. In my bottom base, it looks like I want these lines here to be in back. So let me go ahead and draw those in with dotted or dashed lines. These two edges will be seen, but the edge connecting these two vertices will be behind. And it gives it more of a three-dimensional feeling. Okay, let's go through a few more vocab words. A polyhedron determined by a polygon and a point not in the plane of the polygon. This is called a pyramid. So the base of the pyramid would be the polygon. And the point that's not in the plane, the same plane as that polygon, would be the apex. So this is a square base, there's your apex. Here's a pentagon base with an apex there. All right, and the way that we draw pyramids is you'll draw your base first. Let me go ahead and draw a triangular base. And then draw in your apex, which should look like it's floating above your object. And then you go ahead and connect each vertex of the base to the apex that you've just drawn. After I've done that once, then you may want to go back in and decide which of these edges should be behind, and you'll go ahead and draw those in with a dashed line instead of a solid line. So in my case, I might make these two edges of my base appear as if they were behind my object. And in that way, They give my pyramid a little bit more of a three-dimensional feel. All right, so notice for each pyramid, doesn't matter what your base is. Your base could be a triangle, square, pentagon, whatever you like. But notice that the lateral faces of a pyramid are always triangles. It just so happens that each of these triangular lateral faces are congruent isosceles triangles, meaning all of these edges are exactly the same size, then what you have is a right pyramid. And what you have in a right pyramid also is that apex appears like directly in the middle of your base. And then also, if you have a right pyramid, all of the sides of that base shape have to also be congruent to each other. All right, a polyhedron in which one or more of the corners have been chopped off, that's called a truncated polyhedron. So it could be formed by taking any other polyhedron and just chopping it off, truncating it. So here's a truncated prism. Here's another truncated prism. And the union of the line segments connecting. Okay, so these are all polyhedron type vocab words. Now we'll go through a whole bunch of vocab words that have to do with circular type objects instead of polygonal objects. So imagine that you take your pyramid and keep increasing the number of sides of your base. The more sides that you give your base polygon, the more circular it starts to look. So if you go all the way to create a circular object, a round curve, what you end up with is a cone. It's the union of all the line segments connecting the point P, which is like your vertex or your apex, with the simple closed curve, which is the base of the cone. So this would be a right cone, and this would be an unusual shaped cone, so a cone with an unusual base. And here is what you have, an oblique circular cone. All right, and similarly to a prism, we have these objects, which are given by two congruent bases in parallel planes. And then instead of having the lateral faces all bounded by parallelograms, what we have is an entire lateral surface that is round, that can be shaped along the circular bases. So these are called cylinders. So a cylinder is a simple closed surface. It's not a polyhedron. It's formed as a segment, AB, parallel to a given line, traces a planal curve, something other than a polygon, so some circle or some other curved shape.